Hello grade 12, Mr. G here, and this video is going to be related to momentum and impulse. It's going to be a video to practice the work done about momentum and impulse. This question was a question 4 from May-June 2018. Let's just fix that one. So question 4 from May-June 2018. So this question says a trolley of mass 1.5 kilogram is held stationary at point A at the top of a frictionless track. When the 1.5 kilogram trolley is released, it moves down the track. It passes point P at the bottom of the incline and collides with a stationary 2 kilogram trolley at point B. Refer to the diagram below, ignore air resistance and the rotational effect. Here is the drawing. Here is what is happening. Now, what we need to know, the initial velocity here is going to be equal to 0 because the object is being released. It was held there and they leave it. They release it. So the velocity there is equal to 0. And this trolley is stationary. So the velocity of this trolley initial is also 0. Okay, so that is the drawing and that is the situation of this question. Now, the question 4.1 say use the principle of conservation of mechanical energy to calculate the speed of the 1.5 kilogram trolley at point P. So let's first of all recall the principle of conservation of mechanical energy. It was done in grade 10. There we go. Now this say that in a closed or isolated system, total mechanical energy is conserved. So what we need to know, that the total mechanical energy initial is going to be to the total mechanical energy final for the 1.5 kilogram block. We're working for that kilogram block. Total mechanical energy is conserved. The system is isolated because there is not friction. Okay? So now also remember, how do we calculate mechanical energy? From grade 10 you learned that mechanical energy is equal to the addition of kinetic energy plus potential energy. So from here down further we have that the kinetic energy initial of the trolley, it's only one trolley, we're working with the 1.5, so let's just not write that one, plus the potential energy initial of that specific trolley is equal to the kinetic energy final plus the potential energy final. Remember, we're working with this specific trolley. We are not working with both trolleys. Okay? Now, also recall from grade 10 that kinetic energy is equal to half the product of mass multiplied by the speed to the power 2, and potential energy or gravitational potential energy is equal to the product of mass multiplied by acceleration due to gravity multiplied by the height. Okay, so we are going to substitute all that in the previous equation there. So here we have that half the mass of the trolley multiplied by the initial speed of the trolley square plus mass multiplied by the acceleration multiplied by the initial height is equal to half of the trolley mass final speed of the trolley square plus mass acceleration due to gravity height. Okay, now if we go here, we know that the trolley is not moving start, so this initial here is 0, and we know that the final height when the trolley is here at the ground level, there is not height here is equal to 0, so we have that the final height here is equal to 0. Okay, so this is what we have, and then we can substitute the values now. We have that the mass of the trolley is 1.5, the acceleration due to gravity is 9.8, and the height is 2 meters. All that is given to you. Half mass is 1.5, and the speed final of the trolley, which is at point P, that is what we are looking for. So if you do this substitution and you do the calculation, the speed of the trolley at point P is going to be equal to 6.26 meters per second. That is the answer for this question. Okay, that is the answer for this question. So that is the speed of the trolley at point P, 6,26. So let's write it here in the picture. Yeah, the speed here is going to be equal to 6,26 meters per second. Okay, that is at point P. Now, the marks allocation here, if you want to mark your work, will be 1 mark for the law for either of these formula, either that one, this one, or even this one. Any of those will give you 1 mark. 1 for the substitution on the left-hand side, 1 for the substitution on the right-hand side, and 1 for the final answer, and that adds up to 4 marks. Okay, let's go to the next question. The next question said when the two trolleys collide, they stick together and continue moving with a constant velocity. The principle of conservation of linear momentum is given by the incomplete statement. This statement here is incomplete. So remember, it is a incomplete statement. Now the statement say in either a or an system, the linear momentum is conserved. So what is going to be the first part? In a or an, close or isolated. You don't have to write both, close or isolated. System, the total linear momentum is conserved, and that is going to be 2 marks. 1 mark for this part, 1 mark for the total. Those are the 2 marks. So let's continue. Let's go to the next question. The next question says calculate the speed of the combined trolley immediately after the collision. Okay, so we have to use the law of conservation of linear momentum. Now, what that law state is there, is in the previous question. Okay, now we can say that the product of the mass and the initial velocity of trolley 1 plus the mass and the initial velocity of trolley 2 is equal to the mass times the final velocity of trolley 1 plus the mass, the final velocity of trolley 2. So this is, and we can get the question. Now, important, if we go into the picture, we are going to work from this part here. So from this part here, we have before and after. Okay, so what we have, the block moving at point P for A, and the block moving at point B for the second trolley, which is not moving. Okay, so if we do the substitution, the first mass of the trolley is 1,5. The initial speed is what we calculated in the previous question, 6,26 plus initial velocity mass of the mass of the second trolley is equal to 2, and the initial velocity of the trolley is 0. The trolley is at rest. Here the mass of the first block is 1,5. The final velocity is what we are looking for, and they are moving together. This is 2 multiplied by the final velocity of 2. They are moving together, so the velocities are constant, and this one is a system. You can say actually final velocity bracket 1,5 plus 2. That is entirely up to you. Okay, so what we have here, we have that, let's rewrite that one, 1,5 multiplied by 6,26 is equal to final velocity bracket 1,5 plus 2. This is what we have. And when we substitute this, and when we do calculate the final velocity of the two trolleys moving together, is going to be equal to 2,68 meters per second. The marks here are going to be 1 for the law, 1 for the left hand side substitution, 1 for the right hand side substitution, and 1 for the final answer. Those are 4 marks. And the next question says calculate the distance traveled by the combined trolley in 3 seconds after the collision. Okay, so this is quite easy. We have that they are moving together. Calculate the distance traveled by the combined trolleys in 3 seconds after the collision. Now, before we carry on, we have to come back here, and they say here, moving given by the incomplete, here, when the two trolleys collide, they stick together and continue moving with a constant velocity. Constant velocity, very important. So they're going to start moving together, but they're going to continue with constant velocity. Okay, so with having the displacement, let's first of all quickly write the data we have. Data is the initial velocity is equal to what we just calculated, which is 2,68 meters per second, and that is constant. We also have that the time is going to be 3 seconds, and we know that it is moving at constant velocity, so this is constant. Okay, we're looking for the displacement. Alright, so looking at the formulas, you're supposed to go to the formulas at the back of the exams, and you can see that if the velocity is constant, the displacement is going to be equal to the product of the velocity and the time taken. So this is quite easy. It's 2,68 multiplied by the time, which is 3, and the final answer is going to be 8,04 meters. So that is the question, and the marks here will be one for the formula, one for the substitution, and one for the answer. These are the 3 marks. I hope this question helped you. It's about momentum, but there is another topics that may be asked in the upcoming exams, not only the control test, but I'm thinking perhaps the June or the September. Okay, so thank you very much for watching. I hope you understand, and if you think it helped, please thumb up, and good luck.